finish.
For the next, that's one more. Okay, yeah, people have started joining. Hello, everyone. Thank you so much for joining us. We'll just wait for a couple of minutes, like maybe 1 or 2 more minutes, and then we'll get started. So, yeah, because we have an overwhelming number of registrations for this workshop. The last we checked, it was over 150. So I'm assuming that at least 30 to 40% people will join. So I'll give people some time to kind of join. However, in the interest of time, we'll start in another minute. And as folks join, they can keep posting their questions and everything. Hello, everyone. Hello, Pink. Nice to see you. It would be great since we are all meeting virtually if you could just, let us know where you're joining from. It's also a really good morale boost for the speaker themselves to see that there is an international audience that is interested in attending their talk. So if you just want to say hi and let us know where you're joining from. I'm Gyan. I'm one of the deans at the Education Guild, and I'm joining from Bangalore, India. Hi, Aryan. Hi, everyone. Okay. We have about, okay, we have someone joining from UK. I know that Aryan is joining us from India. Then Okay, so we have about 29 attendees who have joined. I think people will start trickling in. But in the interest of time, let me at least start with the introduction. We have Ravindra Naik with us today, who's the speaker for the session today. And he's a close friend of mine as well and a good acquaintance. He has been an entrepreneur, he's a full stack developer, and he has a plethora of architecture skills in the Web2 space. So he's definitely the right person to be talking about REST APIs because I think he has built over 1,000 of them in just the last couple of years. He recently started dabbling with Web3, which we sort of did a couple of hackathons today. Earlier we started with actually the Covalent, I think the wallet hackathons, and now we are building end-to-end apps together. So that's really cool. So he's familiar with both Web2 and the Web3 ecosystem and definitely has a lot of expertise in the full stack space. I let Ravi take over and maybe share his slides if he would like, probably a brief introduction of what he's doing currently, where he's working, and what intrigues him about this topic that he's going to present. So over to you, Ravi. Just before you start, I want to let everyone know, all the attendees, that uh, we have allocated an hour for the workshop. We'll try to wrap up by 45 to 50 minutes if possible, and maybe leave 10 minutes for questions. Meanwhile, you have the option to keep typing your questions in the Q&A box. It would be easier there instead of the chat. In the chat, we could just chat, if required. But any questions relevant to REST APIs would be great to put it out there in the Q&A box. So yeah, I will stop talking now. We are almost close to 50 attendees, and Ravi, over to you.
Thank you, Gyan, for the introduction. So I'll probably get started. I won't take any more time. I'll share my screen. Please let me know once you can see my screen.
Yeah, we can see your screen. Maybe you want to put it on the present mode. So,
Sure. Yeah, I'll do.
all right.
So yeah, before I move ahead into slides, right, I will probably give a small introduction about myself, right? So I'm Ravindra Naik. I've been working as a software developer for a bit more than about 8 or close to 9 years now, come the end of this October. Right. I started actually my career as an iPhone application developer, went on to work for various products uh, for a startup based out of India, which is where I actually come from, right? So I went on to work for machine learning products, which where I got certain patents, and then I moved on to develop a full stack open source framework called Kitsune that also got patented, and I designed that full stack framework right from design development and took it to production. Where during the first 6 months of the launch, we had close to 250,000 retail paying customers onboarded onto that particular platform, right? So post that, I went on to work for MNCs, again in India. Went on to work on different tech stack, as you typically see for a person who has worked for about 8 to 9 years, right? So, but throughout these 9 years, if there was something that was common from right from the start when actually was working as an iPhone developer, was to work with REST APIs, right? So even as a initial, like even as my at the career start, when I was developing iPhone applications, I was actually building the REST APIs during the night times so that I could consume them the next day when I actually go to work again, right? So I actually, you could say, close to 9 years of building APIs, need not be REST, but developing APIs. So which is why I thought maybe I might have some information on what APIs are and some of the good practices that I learned over a period of time, and I actually wanted to share across to the community. And when it comes to blockchain space, as Gyan had mentioned, I'm actually quite new to the space. I'm actually exploring the W3 space. I've been introduced by Gyan herself to the blockchain by participating in some hackathons. I actually got introduced with 1 million wallet challenge of Covalent, right? And from then on, we have been working across multiple hackathons and trying to build dApps now, right? So that's a quick introduction about me, right? So without taking any more time, I'll probably go ahead on today's agenda, right? So what I'll probably cover today is give a small introduction of what is an API before start talking about what are RESTful APIs, and typical architecture of web APIs. So there are different APIs which I'm going to talk about, but we are going to focus typically on the web APIs for this particular session. And what are different specs that are popular. There might be different specs out there, but I just want to concentrate on popular API protocols that are out there, and what are RESTful APIs, which is the main agenda of this particular call or the workshop, and some of the best practices that I've learned over the period of time, right? And something that I would definitely advocate for people who develop these APIs to keep in mind uh, when they work with the REST APIs, right? And also what's next after this particular session, how are they on person, right? So that's the agenda for this call, and I will start with what is an API, right? So if you are a full stack developer, or if you are a business analyst, or if even if you work with different products out there, right? Even in the business space, you typically hear this term API quite a lot. And if you have, right, so these are some of the keywords that you keep hearing quite a lot, like what is JSON, response, URL, request, method type, headers, and all these things, right? I'm sure like most of you would have heard all these terms, but I'll try to briefly touch upon some of these terms over the period of next few slides, right? And I hopefully will shed more light on, shed more information on what are these and how are they being used in the API space. So what is an API, right? API actually stands for Application Programming Interface, as the name suggests, right? So it's an interface which allows two applications to communicate with each other, right? So what does it essentially mean? Like let's say you have a front-end web app and you have a database where the data resides, right? Front-end app needs the data to come from database, but you can directly connect to the database and retrieve the information. But say the same application has to be served by different clients, like for example, mobile app or iOS app or an Android app and maybe some other application or chatbot, for example, right? So you can't have parallel databases, which is why you will create an interface between one application, which is database, the other application, which is the front end, which can be iPhone app, iOS, Android app, or other apps that I was talking about, right? And this API can help bridge the communication. It can serve as a single point of contact for all the other clients to the server, right? So typically that is what is an API, which is why it is called as an interface, right? And you might not have realized, but in our day-to-day life, right? So we typically use a lot of APIs right from the day starts till the day ends, right? It could be as simple as when you open your phone, you might check the weather information and how the weather would be like today, right? Or if you want to text your friend who's on your Facebook, sending an instant message, or even for business, right? That itself might be an API call, or even the fact that you log into the Facebook to send that message is an API call, right? Even if not, like if the moment you work with certain commands on your Windows or other Mac machines itself is an API call in itself. Not all of them are on web, but even those are API calls in itself, right? So you on a day-to-day basis, like we do interact with these APIs, right? So it's essential that we understand what these APIs are and how best we can use them. I'll give you one more example, right? So imagine you are sitting in a restaurant, right? And you have set of uh, you want to place an order, right? And you already have list of items which are available from the menu. But if you notice that kitchen is an entity, kitchen is a system which will help you serve the food that you would have ordered, right? But you don't essentially go to kitchen to get that order. You wait for an interface or a person called waiter, who you typically put in your order as a request, and the waiter would then go to the system called kitchen to send that information to the kitchen that certain number of orders, that certain food items have to be delivered at this particular table, and this information is then processed to kitchen. Kitchen will take this order and will do some processing, and then sends back the information, which in this case is the food, right? It gets back to the table. So in short, like you can consider the waiter in this case as an API, right? Post this, there are other systems also in this case, like billing, right? So once the food is delivered, once it's cleared out, like you would ideally want billing, right? So the waiter would then probably go to billing counter, take the, since he already has the orders, will give you back the bill and maybe process the invoice and other stuff, right? So here in this case, API is doing multiple things in a certain system, right? For that matter, even not all tables will have menus, right? Not all restaurants will have tables with menus. Some of the places might not. So even getting a menu could itself be an API, which the waiter is doing, right? So in a nutshell, like this is what an API would typically do. It will take a request from certain entity, it would go to a certain system, process that particular information, send back the information, right? In a format that the client would actually expect it to be, right? So I'll give you one more real life example, right? At least in pre-COVID times, this example might be very true, where we typically search for airlines when if we want to travel from one city to other city. And if we do want to do this, we go to a website, airline website. For example, I might be using Qatar Airways, so I might land up on their website. There are different options that are available when I start searching for airline, right? Like when is your departure date, where are you trying to departure from, when is your return date, like preferred time, is there any like hall time that is available, cabin space, luggage space, and all other criterias, right? uh, but these are all the requests, these are all the information that you give in to a particular system which is booking airlines, like Qatar Airways in this case, right? So in this case, Qatar Airways, since you are booking from Qatar Airways site, you have a front end, which is Qatar Airways front end website. And you also have a database, which is where you get information of what are all the flights which are available around this particular time, what are its current statuses, and what are its current price. All this information you get from a singular database, which is Qatar Airways database, right? And but say for the same website, you have one more app, which is a front end app, one more front end app, which is iPhone application or an Android application. If you want to, you can also place bookings from there, right? So if you want to place a booking, and if it also has a database of its own, right? If each of them have a database of its own, then it can't sync the data between multiple database it creates, right? Like one is on a web, the other is on iPhone, the other is on Android, and all these things. It can't sync the data essentially between the multiple data in a real time, at least, right? So it's a challenging problem to have. So in order to avoid that, in order to have one single source of truth, we have a singular database which can be replicated, of course, but there's only one single source of truth, and the API layer comes in between. and tries to connect all the ecosystem of the Qatar Airways, right? But what if that's a typical scenario for Qatar Airways scenario, right? But what if you are using an external OTA like Expedia or Make My Trip, for an example, right? So they don't have an information of the database, or they don't have the information of this database, and not they can directly interact with their database, right? So what they typically do is Qatar Airways provides an interface like APIs to Expedia.com or MakeMyTrip.com to get all this information, like what are all the flights which are available and what are its current costs, and what other information pertaining to this particular trip, right? So all these are exposed through APIs, right? That's essentially that we are using already in our day-to-day lives. Okay, so this is something that probably you could connect to, uh, at least in pre-COVID times, if not now. So just to touch more on how we are using REST APIs without even understanding, right? Like without even putting focus that we are actually triggering all these API calls, is when you're playing a game, when you're watching a TV, when there is an ad on your TV, right? Or when you're watching some screen on when you're watching a movie on a mobile app, or when you're actually opening a mobile app itself, right? Or when you're working with an enterprise application, uh, when you're driving your car, all these web applications that you browse on the internet, and even wearable devices across all, even for that matter, some sensors which are placed on your home, at your home, right? So at most all these places in a digital space, we do have APIs, and they do interact with some of them on cloud, some of them are not, but they do have APIs, and we do trigger them from time to time on a daily basis. Right? So, but we don't realize essentially on how we do it, right? As I mentioned at the start of this agenda, like there are APIs, but they are not just web APIs, right? There are different types of APIs, and there are more than the three mentioned here, but uh, popular APIs that I worked with are the database APIs, operating system APIs, and web APIs, right? There might be some other APIs that might be available, but these are the APIs that I'm actually quite familiar with. So I've just put across this. So database APIs is an interface where it allows us to communicate with the database and get the information that we would require, right? So these are something that we typically as a backend developers interact with database and give out the information that we need, right? Or even for business analysts, for example, or operating system APIs, right? So we tend to use this operating system APIs on a day-to-day basis, but we don't tend to realize that we do, right? So like, for example, I'm just giving it as an example. Like if you open terminal and if you put in certain commands like list commands or some other commands, internally it might call some other API to get the information that you are looking for, right? So operating system also has APIs, and web APIs, of course, which is what we are going to talk about for the rest of the meeting, right? So how would a typical architecture of a web API look like, right? As I'd mentioned, as I'd given the example of Qatar Airways, or even in case of hotel or restaurant, right? The single source of truth, which is database. Of course, it can have the same data spanned across multiple read replicas, or it might be spanned across different data centers as well. But there is one singular, like, write only operation, which is the database itself, right? The entity called a database in itself. And you would typically build an API layer, which is what you have in here, and serve different clients, right? I might have mentioned only 4 here, but there are different clients out there, right? Like one is Android, the other is iOS, the one is web. These are typically the popular ones. But if you have your app working against car, you will do this. If you have your app working against some sensors which might be placed at your home or in some other machinery, that could also be one. Or there could be chatbots. There could be any number of clients that come. But the source of interaction would be the API, that, as I had mentioned before. And you don't essentially feed the information directly from database to the clients as they would have requested for, right? So what, like for example, there is an API called get person information, user information, something like that. And user will have a lot of information, right? They have their own personal information. They might have their bank account related details. They might have their KYC related details, which essentially not all the consumers of a particular application should be able to retrieve or see the information, right? So in order to hide this particular logic from, you typically have business logic be a layer inside the API itself, right? So what essentially API means, it's a contract that is defined between a client and a server, that I will give in a request in a certain format, and you process the request and give out a response in a certain format by shielding out certain information or by processing a certain information based on the business logic, right? So this business logic essentially can be called as a function call in itself inside API. So every API will have a function call. Inside the function call, you will have business logic, which will interact with the database and do the necessary actions and return it back to all the clients, right? So this is how a typical architecture of a web API would look like. Most of it than not, this is how it would look like. Not in all the cases, but this is an ideal system that I would think of developing, right? And when it comes to like I mentioned, there are different kinds of APIs, and even when it comes to web APIs, there are different kinds of protocols or specifications that are followed across the industries as a standard, right? So one of them, which was quite popular, which might be still quite popular in enterprise applications, was or is SOAP, right? So what is SOAP? The other is REST, which of course is something that we're going to talk about in detail. The third one, which is of course picking up off late, is gRPC. We might not deep dive into this, but this is also something which is quite popular in terms of API specifications, right? So what is SOAP, right? So SOAP, as I mentioned in here, SOAP actually stands for Service Object Access Protocol. This was actually developed by Microsoft. It's a specification wherein the information, as in the request and response, is carried out in the form of like XML, as you typically as you see in here, right? So it has a specific designed schema as a part of the contract, and you would have to send in the information as an XML, and you will get the information as an XML. And as you see, it's not highly readable, but it actually quite works quite well for an enterprise-based applications who are looking primarily at a security perspective. And also, I think SOAP APIs are primarily have been consumed primarily in payment providers, or maybe even like identity management systems, for example, right? So popular payment providers like PayPal public APIs are actually SOAP APIs, if you look at, right? So their contracts would look something like this, where they use still the XML based specification to interact with different clients or servers. Of course, like I actually worked with certain APIs, SOAP APIs, though it's not my preferred way of developing an APIs. I thought I should just show this information as well, right? So that there is an API specification called SOAP, which is equally popular, not as popular as REST, but it is popular, particularly in enterprise-based applications. Actually, it was developed initially to support the mail transfers and SMTP kind of communications, sending out the emails and all. And I think it would have been extended after sending out the messages to send and receive messages in the form of XML between two different services, right? So that's how I think SOAP API got evolved after a point of time. I will also touch upon why I don't prefer SOAP APIs, but I will first talk about what are REST APIs, right? What essentially means, what does REST essentially mean, right? REST actually stands for representational state transfer. Okay, so what does it mean, right? So it actually represents a state of a particular database at a period of time, at a certain point of time, right? So what was the state of a database at a particular given point of time would be represented by certain resources using REST. So that's what it essentially does, right? And it's actually based, like I said, it's a web API, right? It's based on web standards, and it actually uses HTTP protocol to communicate between client and server, right? So it is based on HTTP protocol. The primary idea of REST is to have, or the architecture is around resources, right? So it is a resource based architecture, as you say. So what are resources, right? So typically when you work or develop as a certain systems, Like for example, you're developing a hospital management system or something like that, right? You would have typically different entities like doctors, nurses, machinery, building, and different entities or different resources that come across in a hospital building management system and all, right? But if you try to access a particular resource or try to access an information on a particular resource like person, and person might be of type doctor, nurse, or some other job type, right, in a particular hospital. Everything, your API should be, or your system should be built across this particular information called as resource, instead of certain URL giving out information about resources, systems, all of them in a certain URL. Instead, REST API actually says everything has to be architected around a particular entity called as resource. For example, let's say you in the HMS system, hospital management system, you are trying to access, or you're trying to get an information on um, who are all the doctors who represent a particular department called ontology in this particular hospital, right? If I want to identify doctors in this certain department called ontology and in a particular hospital, my typical API would be like, you are actually interacting with this resource called as doctors, right? Or it could also be person in your database, but I'm just assuming it would be doctors. Uh, but for the scalability, you might do it as a person also. So you are essentially working around a resource called as doctor or a person. That's how your API would structure around. And whenever you want an information around, of doctor, you would work with a resource called as doctor, right, or person. But if you are looking for billing, then your information would be around billing, or your resource would be around billing. So that's how you structure your APIs, right? And as the next point also says the same, that there is a server which provides access to this particular resources, and there is a client which accesses this particular resources and works around it, right? Like it will add more resources, as in like add more entries of that particular resources, modify the entries of the resources, and maybe update or delete a particular resource as well, right? So not resource, instance of a resource, essentially, right? So that's how you typically interact with a client server communication, as with most HTTP protocol based communications, right? So each of these resources are actually identified by global IDs, which we typically call it as URIs or URNs. So a typical, I just want to show one picture on typical resource, right, and how each of these terms come across, right? So if you look at this particular entry, like you'll see that um, this is a URL, right? Where in the URL, like if you, and this is actually URI, which identifies that there is a resource on the internet, which gives information on blog posts from this particular website called ravindranike.com, right? So if you first notice, this is the method that I'm going to use, or the protocol that I'm going to use. Actually, it's protocol, and the method is going to be get, because you're getting the information from this particular resource. This is a protocol. There's a typo there. This entirely is a URL. What is URL? It is a uniform resource locator, which means it just tells us the location of a particular resource, right? And what is the resource that we are trying to work with? It's a resource called as posts, right? Blog posts. So the resource is post, and this is the actual the location of this particular resource, and put together it's called a URI. It's a unique identifier to access this particular resource on the internet, right? And there's one more concept called as URN, which again is a named entity to identify a particular resource. So it actually doesn't start with HTTPS. It starts with URN colon double slash or something. But it what if it were instead of HTTPS, if it were started with URN, this part of the identifier would have been called a URN, right? So what it means is it uniquely identifies a name for a particular resource, right? So yeah, this is how you can identify what is URI, what is URL, and what is URN, what is the HTTP method or protocol that you've been using, and what are the resources, where is the location, all these terms that you come across for a unique identification system and on the internet. This is how it is structured, right? And as I mentioned, like REST APIs communicate over HTTP protocol and popular HTTP methods. I'm not showing all the HTTP methods, but I'm just putting across popular HTTP methods which have been used on a day-to-day basis, right? So one is obviously to post API, post my HTTP method will actually add to an existing resource. Like for example, if there is a schema called as user, and if there is already a user called as Ravindra Naik, and if I have to add one more user called Gyan Lakshmi, for example, I will typically give in the request, I will say name is Gyan Lakshmi, age is 30, and post this information to our API. You typically use post method to add to an existing resource, right? So this is one of the popular methods that you typically use on a day-to-day basis, right? So while developing APIs, at least you, and get is obviously to get a particular resource, right? For example, if you want to get an information like regarding this particular user called Ravindra Naik, you use a method called as get to let the API know that you want to get that information, not to post an information, right? So you use get method to get an information. You use put method to override an existing resource, right? Like my name is there, Ravindra Naik. It is my unique identifier, maybe some 1234, which is my UID, for example. And if I want to update or override my existing information on my contact details, I might have changed my place, or what are the other information. So I want to override my existing information which is present on the servers. I typically would use put, right, which will override the existing information but not the identifier, right? What would be patch? Patch would be like if you want to update a certain part of the information. Here input, you update the entire information, pretty much the entire information, but in patch you typically update a certain part of the information. Maybe you're just updating mobile number, which has been changed since I moved from Hyderabad to Bangalore, which is like different city. I might have changed my mobile connection, whatever, right? So if you want to update a part of the resource, then you typically use patch. So not all developers do differentiate between put and patch. Like I just wanted to put it across that patch is the method you typically use to update a certain resource. And delete is when you want to archive a particular resource or hard delete your particular resource, right? Like if for example, I might have signed up in Facebook, but I no longer want to use Facebook resources, right? I don't want to use Facebook. Then when I say I want to get removed from this particular system, they typically have an archiving mechanism, and that you typically do using this HTTP method called delete, right? And there's one more method which we might not use on a day-to-day basis, but it is quite helpful, which is head. Maybe think applications like browsers actually use head when they try to retrieve an information regarding a particular resource. Like for example, if my API is being accessible, or if my API is actually allowed on some other domain, right? Like my API belongs to ravindranike.com, and if certain API, certain domain like Covalent is retrieving or is trying to ask some information from my API, whether my API is essentially saying that is this communication allowed between different domains or other informations, right? All these type of header informations come from this method called as head, right? So these are all the popular HTTP methods that you might be coming across. So how a typical HTTP request example would look like is this, wherein HTTP method would be get when you put in browser, or if you use any HTTP client. And this is how your URL might look like, right? URL might look like. And these are some of the headers, right? So whenever you access a particular information, you might be passing this information. So there might be some issue here, like you might not essentially push this information, but you would typically push certain information like header, accept. What kind of information do you want to accept? Like whether are you expecting it HTML format, or are you also expecting image and JPEG? But if you want to block a certain resource, you can also say that, right? Like you only accept certain set of information, particular URI. Whereas like if you want to block, you can also block the other part of URI. You can do that using these headers, right? Using these headers, we will, the browser or the client knows what kind of information can be removed out, or what kind of information can be accepted as a part of the response, right? And typical response from a server would be something like this, right? Wherein it says, what is the status code? I'm also going to touch upon different status codes, but it essentially means whenever there is a successful response, it would probably go give us 200, okay, which means everything went well as expected. And these are all some of the information that we might get in response as a headers, saying that this was when it was getting created, this was the server information, this was when it was last modified, this particular URL was last modified. And key tag is essentially to let maybe caching know, right? Like if the browser wants to cache this particular information, it would typically cache using this particular key tag, or server wants to cache the information that you got just now, so that you don't interact with the database on a day-to-day basis, right? If a resource doesn't change as often as like in every few seconds, then you typically use cache or some other mechanisms to make it faster, to serve it faster to the end user. You typically use headers like e tag to perform that. And the response would come something like this, wherein you get the HTML for the request that you would ask for, right? And as I said, these are all the response headers put together. It's called response message headers. This one is called as response message body. When you get it in a form of message, there would be a space between here. There's a status line, there's a blank space in this message header, and then there is response headers. Then again, there is a blank space. After that comes the response message body, right? This is how a typical HTTP response would look like. And when it comes to API, REST API, so we typically work with resources like I had mentioned, right? So typical URL would look something like this, wherein you are interacting with a resource called as city, right? You are trying to, let's say you are trying to identify all the cities where a particular user might have been in recent past, right? If you want to develop such API, your URL might look something like this, wherein one would be the user ID of that particular user, and cities is the information that you are trying to retrieve, right, for this particular user. So looking at this particular URL, you can easily identify what is it that this particular API or URL giving out, right? What is it supposed to give out ideally? So this is how the URL is structured. The HTTP method that I might probably use here is get, because we are getting the information. We are not essentially posting this particular information, right? And you might also send certain other headers like content type. What is the type of information that you are sending in? In this case, it might not be very appropriate since it's get or like what is the kind of information that you might be expecting. Sorry, that could be like you are expecting it in the form of JSON. So content type would be JSON. Authorization is some, if not all APIs are public, right? So if at all certain API requires certain access, like user access, then if you get it in a form of JWT or username or password or whatever form it is, you will also add in certain headers like authorization, which will help you authenticate and authorize. Post that, you will get the information that you are supposed to. So it's being done using headers in an ideal case. And REST API response, this is how it would be again, right? On a similar lines with HTTP, but some more information, right? So like the status code again, as I mentioned, with some latency, like the time interval as well, that how much amount of time did it take to actually serve out the request that you had asked for. And even in this 230 milliseconds, you will get a breakup on, like you can get a breakup on what is the latency, what is the connect time, and what is the response time from the server and all that stuff, right? So you can look at this particular 230 ms and identify where is the server and how close is the server and how can we actually make it better. And if you want to do that, then I think you can even look at the response to identify this particular information. And like I'd shown before, like all these are the response headers that come along with it. Some other key headers that I typically use on a day-to-day basis is keep alive, which is to, like, whenever you send a request, there is a HTTP connection that gets created, and how long this HTTP connection should persist, so that whenever there is a new request that comes along, it should not create a new connection, right? Ideally, if the connection is already established, why can't it use the same connection to serve one more request from a same authorized or from the same source or an authorized source? So typically you use keep alive as a header to let the server know how long should it wait before closing that particular HTTP connection, since the handshake is already made, right? So these are all type of headers. There are actually a lot of headers that you could add, and you can in fact add your own custom headers while developing your API if your server needs your own custom headers, right? So that's also something that you can do. And the response body might look something like this, wherein it says what is the status. Of course, the status code is already here, but if you do want, you might put it here. Message might be for error. If there was a scenario where there were no users found, or the ID didn't exist, user ID that you provided didn't exist, or some other thing, you could use the message object in here and pass out certain information, right? But the data here, as you see, is that particular information, that particular user might have been in Hyderabad and Bangalore. These are all the different cities that are in India, right? So this itself, this particular information that you see, it's an addition, it's a representation of a data. This is called as JSON, right? So this is quite popular when it works with, when you work with REST APIs. This is one advantage that we have with SOAP, which was like a very big XML, which is hard to read for a native user. But for any developer or in non-developers also, if they look at this particular API, they could easily consume this information. And as I mentioned before, for every API request, when you respond, you should typically respond back with a response code. This is a good practice if to use these response codes as mentioned, right? Not all developers might follow, not all APIs might follow the same this thing, but this is very good. This is very good learning curve that I had over a period of time. That to put out the right informational code, right? HTTP response codes actually helps when it comes to API being consumed by different clients, right? So we have the series called 100 to 200, which is for informational codes. For example, if at all there is a client request that has been made, and some information, and you don't have the information from the server, but you want the client to continue that particular request, then you probably use a request status code called as 100, which means continue, right? You let the client say continue with your request. I don't have the information regarding your request processing now, but you can continue with the request or something like that, right? So in those cases, you will typically use 100 to 200, and 200 to 299. These are all the successful codes, right? So whenever you ask for a certain resource, or like for example, you get the list of cities for a particular user, you when you get that information, you typically respond back saying, I got what is expected from this request, right? So it will give out saying 200. But if there was no data for that particular information, you could have either chosen, you can return back empty object and say 200, or you can also say there is no content for this particular resource and respond back saying 204, right? Which means no content, right? But there was no mistake from the client or the server, just that the data was not found or data was found, right? In that case, you can use 200 or 204 appropriately. So 200 to 299 is where when you is a good sign for a HTTP call, right? It means like everything went as we expected. And 300 is when 300 to 399 is when you typically have redirection codes, like a certain URL was there and is now being moved to different domain or different API. For example, like earlier my APIs would have been on ravindranaik.com. Now I might have moved it to api.ravindranaik.com, right? So all those URLs which were earlier used, like all those clients who are using ravindranaik.com will automatically be redirected to api.ravindranaik.com if I use the 300 code. Not automatically, but it will at least let them know, okay, the resource has been moved to this particular URL. And 400 essentially means that whenever someone is sending that particular request, the client is sending that particular request, he might have done some mistake, right? For example, URL, if in the case of cities, if there was a typo in the URL formation, then the resource might not exist in the API. That particular URL might not exist in any servers. Then in that case, the server might respond back saying that, or browser might respond back saying that this particular URI doesn't exist, right? Or in case of user ID, getting the list of cities for a particular user ID, if you pass wrong information, like instead of giving 1, you pass A or you pass Ravi, right? In that case, you are essentially expecting user ID, but you got user name, right? Which is an incorrect information for that particular request. So you can say it's a bad request. You are not giving in the request as it was expected, right? So those cases you can use 400, and 500 is when you use when something is wrong at the server side. The 400s are when something is wrong at the client side, right? But there could be an issue at the server side, right? When certain request is created, but during the process in time, something had gone wrong, right? So that time you typically use 500. Like if developer basically like 500 is used when developer screws up, or like 503 is when your entire API server might be down, right? It might be taken down, and for various reasons. So there, in that case, you could give 503 or different status codes, right? Typically, when server makes mistakes, you respond back saying 500. So these are this is how you typically structure the response codes, and you should definitely use them when you should definitely consider using them when you develop APIs. So some of the key advantages that we see with REST APIs, which might not be in the case with SOAP APIs, is that it is stateless, right? What do you mean by stateless, right? So stateless, when you say stateless, it means that when a certain request is reached out to a particular server, whatever information is required to process that particular request, all of them is being passed at this particular request itself. Like there is no part of the information which is stored on the server. Like for example, typically in SOAP APIs, people tend to save certain information like authentication related information or server info related information on the server itself. So so all this is not a good practice, and it's not really great for scaling your applications that you save the state of a session on the server, right? But with REST API, all the API calls are stateless, which means like any information that you require to process that particular request is part of the request itself. So you need not save anything on the server. You just take the request, process it, and send the response. So which is why it is called stateless, because there's no information uh, to which is residing on the server to process this particular request apart from the contract itself, right? So this is stateless, and obviously it's good for distributed systems, right? So if since it is stateless, you could probably scale it. Since it's stateless, you can probably scale it to handle several thousands of requests within a matter of few minutes or seconds, depending on how robust your APIs are. Yeah, as I said, like because it is stateless, it is highly scalable as well, right? So yeah, so that is some obvious advantage when you work with REST APIs, provided you develop it well, right? And as you have seen, right, like the URLs itself, they're pretty the URI itself tells you what is the information you're getting, and and the JSON representation also helps it by giving us information in a smaller payload, the smaller data, I mean, and readable data also, right? So it is quite developer friendly. And the other advantage is, since the representation format, most popular representation format is JSON. It's not the only format, but JSON is being used quite heavily for developing REST APIs. Then uh, SOAP APIs use XML, which are quite heavy for the server. So if you are using a mobile network which doesn't have a proper internet connection, XML requests might take longer than the JSON request, right? So if since JSON are by themselves like very small in size, your requests are much faster, and hence they are much more scalable, because the amount of time that it takes to process a particular request at SOAP is quite high than when you compare to REST API. So this is obvious advantage that you see with REST, right? Provided again you've implemented it well. And one more advantage that you'd see is REST API is not just REST API, of course, is used to develop products. But if you look at today's world, right? So REST API in itself is a product of its own, right? API as a code is a product, right? For example, I can think of is Covalent in itself, right? So there's a lot of data which is present on chain, and Covalent gives out information in the form of APIs. So essentially, the APIs are itself a product which Covalent actually gives out to its customers, right? To give out all the information from chain in the form of easy easily usable or readable APIs, so that they don't have to go and dig into the blockchain contracts and read those events and read the transactions and all that stuff, right? So you can just use APIs. So in it, APIs are itself are becoming products in itself, and since they are becoming products, they will have their own software development life cycle, right? So you'll have a detailed phase out designing time, building time, maintaining time, testing phase, deploying phase, versioning of these APIs as well as the documentation. So all these are different stages when it comes to developing any software. Same with APIs also. You should definitely consider considering all these phases when you develop the APIs themselves, right? And on top of what I was already suggesting, some more best practices could be, which might not be which might not be followed by all the developers, but it's widely accepted that this is a good practice, is to use nouns when it comes to URLs and not verbs, right? Like for example, I mentioned in the slide as well, when you get an information about users or cars, you it is a get method anyways, right? And you are getting cars anyways. So your URL should not have get car, all cars. It just could have ended with /cars, and method anyways was get. So you need not use verbs, right? You should use nouns and work around with it, right? So typically in this case, it would be /cars. And if you're getting get all users, it will be /users, right? That's how you typically use. And sub resources, even in the case, right? If you want to identify who are all the drivers for a particular particular person who's identified by this number called as 711, then it is a sub resource. It is not a resource. It is not a singular resource like users or drivers. It is a sub resource, driver of a particular user. So whenever you work with certain cases like that, you use URL in this particular format, use sub resources, so that you get information of a particular user. You get information of a particular driver belonging to a particular user, right? So you use both the resources, and you work around with the sub resource in this case, right? So this is one good practice to keep in mind, instead of directly calling /drivers and passing the information of user along with it, right? And error codes, like I mentioned, all the different status codes and are quite helpful, but if more so when it comes to errors, right? Which is when everything goes good, you typically don't bother much with status codes. But if something goes wrong, that is when you would have to notify either the client or the server that something has gone wrong, and where does it go wrong. Based on different status codes, a developer or the person would know uh, what actually happened, and if it's possible, written out a proper error message as well, so that it can be resolved, right? So error codes and with a proper messages is something that you would have to keep in mind for all the scenarios, right? And HTTP headers, again, like use your custom headers or use the industry standard headers, like accept content type for serialization, right? So when it comes to data format, you might have your REST API serving both JSON, XML, or some other formats as well. But if a user wants only JSON format, then you should be able to give in that option to say that I only accept content of type JSON, right? Or for serialization or something like that. It actually helps quite well if you maintain what are all the content types that you as a server respond back, right? If you could mention the serialization format, that would be quite helpful as well. At least that's what I've noticed. Like I do support some of the APIs that I've developed. I do support both XML as well as JSON to serve different use cases, of course. And avoid get to alter. What this essentially means, like some certain cases, like when you're not essentially posting a resource, you're performing certain action on a particular resource, right? Like user, if you want to activate a particular user, you should not ideally do a get, you should do a patch, so that there is a change in a certain state of that particular resource rather than getting the information. It's not a good practice, because I do understand that here you're not passing in any other request, right? Like there is no request payload along with this URL. But important fact is that you are changing a state, right? If you're changing a state, then you should typically go back to either patch or put, depending on what you are doing, what is the type of action. So you should never use Git to perform this action. This, I think, is one of the most common bad practices that I have seen across my time here. Right? And versioning, whenever you develop the APIs, it's important to keep versioning in mind, right? The moment you develop your APIs and it's being consumed by different clients, and if at all there comes a time when you had a change in mind, or business logic has to change to scale or to serve a different customer, then you can't change the API directly, right? You have to create a new version of the API which serves the new clients, and at the same time it serves the existing clients, right? So you have to think about versioning from the time you develop the API. So there are obviously, I'm not saying what is a standard way of doing versioning right now. There are multiple ways of creating versioning. Like you can do it from URL, you can do it from headers. I am not preaching against which one to implement, but it's important that you keep this in mind when you develop APIs, right? So some other things like plural nouns, as in this case, right? Like if you're getting users, or if you're working on a resource called a user, don't create URL based for user, right? Create it for users, so that you get list of users. You perform actions like on, and when you want to perform actions in bulk, you use plural nouns, right? So it's essential that you create all these URLs in a plural nouns. And aliases for queries. Even this is quite important, so that we structure your URL in a good readable format, so that whoever is consuming this APIs, they look at your documentation, they know exactly where to go, right? If it is users, it has to be under users. And if user is doing certain action, if you're doing certain action, like you're creating a user, it should be post/user. If you're creating an authorization token like JWT, then it would be /user/login, right? So you have to create an alias for your queries, so that it would be in a structured format and easily identifiable for developers as well. Querying, there would be certain cases when you will have like, for example, list of transactions on a certain chain, right? There could be hundreds of thousands of transactions. You can't retrieve all of them at a single shot. You would want to paginate, right? And when you do a pagination, you will only say, I only want 10 requests at a particular time. And you'll also say what is the first what is the offset, and what is the limit, and all that stuff, right? So all these things you can do from URI, and take the information from URL as well from the query parameters. But it's best if you use certain specifications like GraphQL or OData. These are some popular tools that are out there, using which you can query the data and return out the data in a readable format, right? We will be covering upon these querying frameworks sometime later, but yeah, there are certain tools which are already available. And one other most important thing which we have to, as a developers, keep in mind is testing. When I say testing, it's not just unit tests that you would have to write, right? And not just end-to-end tests that we typically do in our CI/CD pipelines. We would also have to we have to also look at performance testing, security testing in mind. These are some things that I'm not sure, like, if a lot of people do keep in mind while developing these APIs. So they have to make sure, as a part of the software lifecycle, as a part of API lifecycle itself, you have to consider this while developing the APIs in itself, so that you can write your code in a performance efficient way. And unit testing has to be supported. End-to-end testing has to be quite seamless, and security testing is taken care of, right? So more in terms of status codes, right? So these are all some of the status codes. There are of course a lot of status codes. I'm showing you some 7 to 8 status codes which are frequently used, right? 200 is for okay. 201 is when new resource is created, new instance of a resource is created. 204 is when you have, like, let's say for example, a resource is deleted, but when a resource is deleted, you don't have any other information about a particular resource. So then you would probably say 204, which means no content. 400 is, as I mentioned, bad request. 401 is when unauthorized, right? So if you authorize, if API expects you to give an authorization key, and if you haven't passed that information, then you might respond back with 401. 404 is when URL doesn't exist or resource doesn't exist, and 500 is when your server, when developer something does something bad on your code, or something goes wrong on your application, right? These are all the typical status codes that we have as of now. And I also actually wanted to show some real life examples, which I have actually developed. So this is one of the platforms that I had developed as a side project in itself. So if you see, like, I try to incorporate some of the things that I just put it in the slides, right? Like, when it comes to aliasing the queries, it's based on account. If you are querying based on an account, I would typically have my URLs like this. And if you look at the URI itself, you know that it is API and all that stuff, right? And versioning, actually I've been doing based on headers, so you won't see the information in here. So, but it is already there. There's only one version, but the versioning is already been taken care of as a part of header information. And if you also see that I'm using get to get addresses of a particular consumer. If you see, address itself is a resource, but address of a consumer is also a resource. So I'm actually using sub resources to get information accordingly. And I'm using get because I am just getting information of a particular consumer and on the addresses and all, right? uh, there's one more API actually, which says like API slash consumer of ID slash address. That is also an option. This is also an option that I have, right? When it's deleting, when it's put patch and all that, right? I'm not essentially patching any information in here. Otherwise, you would have seen some patch also. But primary intention is that you use appropriate status codes and you return out appropriate status codes as in here, and you work with plural nouns, and you use nouns, and you use sub resources. All the information that I had just mentioned, right? So if you want to just have a quick look, this is one API that I tried to use the best practices that as much as I could, right? I also have a link of HTTP status codes if you want to just have a look at what API is good for what purpose. So I can also post that in the chat here if at all you do want to have a look at it. And post this, right? What is next? Once you know these are all the best practices, we want to actually continue this workshop to give a hands-on API development and the testing at a later, sometime later this month. I hope, if at all the slot is available. So we would be covering that. Right? So these are my communication addresses. You can reach out to me anytime, either on Discord or on Twitter. I'll try to be as responsive as I can. And but if you do have any questions, I guess we do have some time now. If I'm not wrong, we can take that up now.
We are actually 2 minutes over time, but we can still, if everybody is okay and they have any questions, we can extend by 5 minutes more. I haven't seen any tech questions come in so far. I've been keeping an eye. But if anybody has any questions, please feel free to post it on the Q&A. Or for those of you who are new to REST API, you probably want to watch the video again and be able to absorb the information that was given during the workshop, and you can also come back and ask your questions on Discord. However, there have been a lot of questions around the POAPs. For this workshop, we do not have the information regarding POAPs yet. However, we are planning on giving out the POAPs. So the moment it is ready, we have all of your email IDs as you have registered on Zoom to attend the webinar, and we'll be sharing out the POAPs through email. So watch out for that. It will be coming soon, sometime at the end of this week, or probably early next week, as we are just setting up the Alchemist DAO and creating the POAPs accordingly. So that's that about the POAPs. And if you have any technical questions, you can post on the chat or on the Q&A. Otherwise, I think we'll wrap up, and we'll also let you know when the next workshop in this series would happen, probably end of this month or so, as Ravindra mentioned with a couple of other alchemists. And yeah, thanks everyone for joining this workshop. It was quite insightful. Thank you, Ravindra, for taking out your time and being able to share with us all the information related to REST APIs and best practices in writing them. I'm sure this would set the pace for the upcoming workshop, which would be more or less hands-on, where people may even learn to write their own APIs, play around with it, maybe use some postman calls to test it, see the response, etc. So that would be really helpful. And yeah, thanks everyone for joining us. And look out for the next workshop. And we have some other interesting workshops on the agenda as well from the Education Guild coming up. If you are interested in joining the Covalent Discord, I've shared the Discord link on the chat as well. As we are a DAO now, it's a gated community, so you would need one CQT, that is Covalent Query Token, to be able to become an alchemist and join the different guilds. This workshop is hosted by the Education Guild, and if you want to join the Education Guild, or if you want to present workshops or write some content, create some content, you can join the guild. You would need one CQT to become an alchemist and join the guild of your choice. So that's that. We'll be releasing some content on that very soon. Yeah, lot of thanks to Ravindra. I also see on the chat that the workshop was very helpful and very informative. We look forward to hosting you again for the next workshop in the series.
Sure. Thank you all for making time and joining this call. I know it was a long call, I guess, right? I extended by at least 15 minutes. So
That's
thanks
okay.
again in the
You
call.
know, actually, we generally see a drop in the numbers as the call goes after 30 minutes, 40 minutes. But surprisingly, for this particular workshop, there was no drop in the numbers. There's consistently around 70 people attending the call, because I think REST API is such a popular topic, and whether people are wanting to start their first development job, or they are looking to explore full stack development, or just learn about APIs in general, I think this was a great place to start and understand right from the foundations. That's why we had the audience stick with us throughout the end of the workshop. So that is really great. um, yeah, awesome. Yeah, a lot of people learned a lot. That's great. Thanks everyone for your time from wherever you have joined us. Have a good evening, good day, and a good start to your morning. And we'll see you in the next workshop.
Sure. Thank you. Have a good day. Bye.